This is Geometry's Measure and Classify Angles from Unit 1. We're going to define an angle. An angle is made up of two rays. We can name those rays using letters that are on. We're going to name the angle by using letters that are on the rays. We have ray AC, we have ray AB. The notation for this angle, you could use one letter for angle A because there's no adjacent angles to it. You could use three letters, a point on your first ray, always the vertex, and a point on the second ray, or you could go the other direction. Many real-life examples of an angle, you could use the angle of a ladder when it's leaning. Different types of angles. We have an acute angle. An acute angle is always less than 90 degrees. You could have a right angle. A right angle is often going to have a box in the corner. Exactly 90 degrees. Or you could have an obtuse angle whose measurement is greater than 90 degrees. But it's going to be less than 180. You could have a straight angle. You could make an argument that that is opposite rays. That's exactly 180 degrees. A ray that divides an angle into two angles that are congruent. So let's get an angle. If we're going to bisect that angle, that is called an angle bisector. It makes two congruent angles out of our current angle. So if we had the original angle of BAC, we have another point on this ray, then we know that angle BAX would be congruent to angle XAC. Congruent angles. Congruent angles will always have the same measurement. And will have the same number of tick marks. That will be a curve inside of the angle. These two angles look about congruent, so they have the same amount of curves inside. They're in the same drawing, so the same number of curves show that they're congruent. Sometimes you'll see a number 1 or a number 2 inside of an angle. you could say that angle 1 was congruent to angle 2. That's another way that you can name an angle. Next, we have a picture that shows two and then a third really big angle. These are called adjacent angles because they're next to each other. There's different ways that we can name this. We're going to name the three angles that are inside. We could say angle ABC, that's this one on top, or you could say CBA, you could go the other direction. You could name the angle on bottom angle CBD, or you could name it the other direction. You also have a big angle in the middle, ABD, or you could name it backwards, DBA. You could not name this angle by a single letter B. A single letter B would imply that there's only one possible angle. We have three possible angles with the same vertex, so we cannot name it with one angle. You always have to name that with three angles. Similarly, like we talked before, if one of these angles had a 1 in between the two rays and another one had a 2, you could name this one angle 1, you could name this one angle 2. And remember, you should not name any of these angles just B, because they share a same vertex. On the next page, this is called a protractor. Using the protractor, we can determine what the angle degree of each angle is. So to determine what the degree measure is of angle WSR, we need to look for where WSR is. We find the W, the S, and the R. We determine that the angle is opening up to the left. We find out where the side lines up to 0, and we use the numbers that start with 0. So 0, 10, 20, 30, 40, 50, 65 degrees. So we would put an M in front of our measurement, and that equals 65 degrees. Next we have angle TSW. TSW. You got to find the letters, find where we start with 0, and then from here we say 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 115. We must put an M in front of the angle symbol to represent the measure of angle SWT. Or sorry, TSW. We did not use the M on the previous page because it wasn't an angle measure. Those were the actual angles. Here we're looking for RST. RST is going from 0 all the way to 180. It's a straight angle, so we know the measure is going to be 180 degrees. VST, starting at 0, goes up to 90 degrees, so the measure equals 90 degrees. If we're going to classify our angles, because angle WSR is less than 90, we know that this would be an acute angle. This one's more than 90, so it's an obtuse angle. Angle RST is exactly 180, so it's a straight angle. And then we have a right angle because it's 90 degrees. So we're going to come down to the next. We're going to name all the angles in the diagram. So we can first look at this top angle. What do you think? What do we start with? Angle FGJ. Or you could go the other direction. JGF. You could name the angle to the right JGH. Or work backwards, HGJ. Now we could look at the big angle. Because we have multiple angles with the same vertex, we cannot name it with just a G. We have to name it with 3 letters. If you're uncertain, you can always name it with 3 letters. Angle FGH or angle HGF. For example number 4, we look at the type of angles, or what type of angles do the x-axis and y-axis form. Here we have the x-axis and the y-axis. So what type of angles do those look like? Do they look all acute, obtuse, or right? They should be right angles. Typically we'll have a box in the corner for a right angle, but with an XY axis that's not common. With the final construction, we need a straight edge. You can use the battery holder of your calculator, your graphing calculator, if you have one, or any ruler, your student ID, anything that's definitely straight on the edge. Use a straight edge to draw and label an acute angle. So we have one ray, put an angle out over the edge. It could open up, go the other direction. We could label it point X, Y, Z. Oh, sorry. They wanted us to name it A, B. Because B is the second letter, B has to be the vertex. The A or the C could be on either side. Next, we're going to fold the paper so that the 2 rays line up right on top of each other. Got to be careful and precise so that it can work. If you fold your paper, and then you can see the crease. The crease should show the angle bisector. We could label a point on that label angle bisector, maybe H. So now I know that angle ABH is congruent to angle HBC. Notice we do not put M's next to the angle symbol because these are not measurements. These are the actual angles are congruent. Congruent means size and shape. Alright. They suggested to use a D, I put an H. Nonetheless, they would be congruent to each other. A protractor would help identify that.